start off with this lesson that is very foundational in principle, and just want you to understand some of these concepts that will really help set the foundation for the next unit and beyond. So first of all, some review, like what is an inverse? We want to explore this. What is an additive inverse? Well, the additive inverse of 4 is -4. Make that a little larger, okay? So -4 is what we would call, with terminology, the additive inverse, which is just simply the opposite, okay? So as you're filling these out, just kind of think about what we're talking about, and we're going to build here. So when we add opposites, just to make sure we understand this stuff from a long time ago, when we add opposites, obviously we get 0, which is called the additive identity. 0 is the additive identity. So when we add opposites, we get the additive identity. -4 is the additive inverse of 4 because of that. Okay? So what is the multiplicative inverse of 4? Well, that would actually be, I don't know why it's not, there we go, 1/4. Okay, the multiplicative inverse of 4 is 1/4. That's called, which you know as a term, as the reciprocal. Sorry about my handwriting here. It's kind of tricky on this. So when we multiply reciprocals, what do we get? Well, you know you get 1. Well, that's called the multiplicative identity. So throwing a lot at you at the beginning here, but understand, like, we're talking about inverses, we're talking about identities, and if you need to go through and really understand that, because we're trying to build up what does it mean to be an inverse. Additive inverse of 4 is -4. Multiplicative inverse of 4 is 1/4. So what does inverse mean? Kind of think of it as simply, hopefully this helps you, kind of undoing operations. Okay, undoing operations. So what's the additive inverse of x cubed? We would say that that's -x cubed, because x cubed plus -x cubed would give you that additive identity, which is 0. What is the multiplicative inverse of x cubed? Well, you guessed it, that would be, 1/x cubed. Why? Because when we multiply those two together, which is actually, remember, just as a note, equal to that, but that would actually get us equal to 1. Okay, so now we're going to switch gears and take it into the honors pre-calc level here, and now we're going to talk about what does it mean to be a functional inverse, or an inverse function of x cubed. So we're still going to talk about x cubed here, but what does it mean to be a functional inverse? Well, I want you to take a look and fill these in. All right, so I got these filled in for you. If you put in a 1 into x cubed, this is, you get a 1. All of this input gives us all of this output. Okay, so in, out. Well, the functional inverse needs to undo that. So what it means is we still put this in now. So like, I put this in, I got this out. Now I take this and put it in, and I should be back to where I started. So what does that? Well, if you're thinking about math here, that would be the cube root of x, right? The cube root of x would be the functional inverse of x cubed, because it undoes everything we had in there, okay? So we should be able to fill in kind of these titles now. So I want you to think about it over here in this space of something we've done in the past, because this is going to be a way to test to see if functions are inverses of each other. And think about the composite functions we've done in the past. So if we did f of g of x, all right, well, for these two right here, look what happens. You take g of x and you put it into f of x. Now, these are very simple parent functions, but watch what happens. So I'm going to take x cubed and I'm going to replace it with this 1. So I'm going to put the cube root of x in here and I'm going to cube it. Well, what happens? One undoes the other, and what do we get out? We get x out. Now, if that happens for both of these, okay, if that happens for both of these, f of g of x and g of f of x, those composed of each other, then they're going to be inverses of each other. So this one would be a tad bit different because we have to take the cube root and replace the inside now with f of x, which would be x cubed. A little different concept, but it still gets you to x. So to fill this in down below, when we compose inverse functions, yeah, I definitely can't write on that line on here, but all that's supposed to fit on that little like line segment that is right there. When we compose inverse functions, when we have functions that are actually inverses of each other and we compose them, we will get x. And that is called the identity function. So these notes are really put together smooth here. Props to Miss Orsi for doing that when she put these together, because what it does is really gets your past knowledge on inverses, identity, all of that, and it puts it together in inverse and identity terminology, which is great. Okay, so really what we're asking you to do here, and you can pause the video and do this if you want to. I think this is really good for your notes here, and I think you should. But basically, we're going to graph both of these together. So go ahead and pause the video, graph f of x equals x cubed with your key points, and g of x equals cube root of x, and then hit play, and I'm going to talk about them. And you're back. I hope that went well. Here's the thing, I did not, I made sure this was done because I can't do this well with this pen. So I've got right here, not this, that's not one of them, but if I highlight here, okay, what I've got is, this is the cube function, and then this one over here is the cube root function. Okay, if we look at those two, they are what we've been talking about, inverses of each other, and this whole we get x thing out tells you that we have symmetry. Where's that symmetry? On this dashed in line here. So they will be symmetric. This is just about to be huge, what's about to happen in your mind. This is symmetric about the line y equals x. So just think about this. When we were talking about f of x up above, I'm just going to pick an ordered pair, we had 2, 8, right? Well, what does that turn into? This point 2, 8 flips to this one right here, which is 8, 2. So on g of x, that ordered pair is now becoming 8, 2. The y becomes the x becomes the y. So essentially, what are you doing? You are essentially just switching the x and the y values. Here's 1, 1. You know what that becomes? 1, 1. Because reflected in this line, that's what it is. Same with the origin, same with -1, -1. But if you go to -8, -2, you know what that becomes? That becomes -2, -8. Or vice versa. Okay? So I'm going to pause the video here because I don't want it to run too long for the recording, and I'll pick up on the back page. But the last note I want you to know is that when these graphs are, when these functions are inverses of each other, you can literally just switch the x's and the y's, and we'll follow through with that. You can see it in these tables here why that makes sense. A 2 in is an 8 out, but then an 8 in is a 2 out, so that relationship exists. And hopefully I can